the two means are equal, what's the probability of observing our data? Our data ends up being extremely unlikely. Okay, meaning the p-value is small. Okay, if our data is extremely unlikely under the null hypothesis, alright, then the fact that we did observe our data, okay, because we have our data right here, the fact that we did observe our data provides evidence that my null hypothesis is wrong. Okay, because we're saying, let's, for argument's sake, say that the null hypothesis is true, that the two means are equal. What's the probability of observing our data? It turns out it's incredibly unlikely to observe our data under the null hypothesis. If that's the case, then we would say, we probably didn't observe it, you know, out of that 2 out of 10,000 times. Okay, probably our initial assumptions about the null hypothesis are wrong. That's what's going on. Is that okay?
So to prove mu1 equals mu2, we want the area to be as large as possible.
Yeah, actually we never say it proves mu1 is equal to mu2. That is just not within our capabilities. Okay? Because the only way to prove that mu1 equals mu2 is to actually find out what mu1 is and to find out what mu2 is. And until we actually get true value from mu1 and a true value from mu2, we cannot prove that they are equal. Okay? All we can do is say, I've observed a whole bunch of data, and it doesn't disprove this. Okay? Yeah?
In that little blurb about p-value being large,
Yes.
The word after conclusion is that the word or?
I am. Sorry.
I am.
Then your conclusion is, I am not willing or able to reject the null hypothesis that mu1 equals mu2. Sorry. Yeah. It's like a second grader wrote it on the board. Alright, is this okay? Alright, so there's one technicality here, alright, and I don't think it changes too much. Alright, the technicality is that my p-value in this exact situation, for this exact problem, is actually double what it is here. Okay, it's actually incorporates both tails, because prior to seeing the data, we had no idea whether toluene should have increased or decreased norepinephrine concentration. So any difference, a difference of positive 96.6 or a difference of negative 96.6, both of those would have been equally interesting to us. Okay? So because both the positive and the negative difference would have been equally interesting to us, when we create our graph, we need to take in both the positive and negative sides of the curve. So our p-value is actually twice this. P-value is 2 times 0.0227 of 0.0454. Sorry, that's even worse. Because it's like so hard to write at the bottom of the chalkboard. 0.454. And this is 45. 0.0454. So is 4.5% small enough for you to ignore? Or is it not small enough? Yeah, question.
So I'm confused with the wording. So if the p-value is small,
Mm-hmm.
hold on, I had it in my head. Are you leaning more towards the alternative hypothesis?
Yes.
Okay. And then if it's large, you're leaning towards the null.
Right.
Okay.
Okay. So a small p-value means the probability of getting your data under the null hypothesis is small. So that leads you to believe that your null hypothesis is wrong?
In general, do we always assume a null hypothesis, not the other way around?
Yeah, you always, in our, in hypothesis testing, we set up a null and an alternative hypothesis. We always assume that the null hypothesis is true. Okay?
Okay, so let's just say 96.6 happened 45% of the time.
Okay.
Big amount. So that's p-value is large.
Yeah.
Then we can assume the null hypothesis because it happens so often.
Yeah, so our if our p-value is large, okay, so it turns out under the null hypothesis, if we assume that the null hypothesis is true, we would observe differences of 96.6, 45% of the time. Okay, if that's the case, then we would say I cannot reject the possibility that mu1 is equal to mu2. Even though my sample means are different, I cannot reject the possibility that it happened by random chance. It doesn't prove that it happened by random chance alone. Okay, we can never actually prove that. All we can say is that because it happens 45% of the time, we're expected to see this 45% of the time from random chance. I'm not ready to say it happened by random chance. I mean, I'm not ready to say that it didn't happen by random chance. Is that okay? I know it's weird. In the beginning, it's weird. You will get used to it because we're going to do this a lot. We're going to do this a lot. Why don't we take a break, 10 minutes, and then